That will be question 47 from this chapter, Distances on Earth by R.K. Bali. Aircraft is at latitude 2 degree north, 20 minutes north, 2 degree 20 minutes north, and it tracks 180 degree, which is it goes in the southerly direction for 685 kilometers. On completion of the flight, the latitude will be how much? On completion of the flight, what will be the final destination or final latitude? So let's plot this. Aircraft is at 2 degree 20 minutes north. It goes southerly direction in the direction of south for 685 kilometers. For 685 kilometers, or you should know this, 1 nautical mile is 1.85 kilometers. So 685 kilometers will be equal to how many nautical miles? Cross multiply 685 divided by 1.85. So that will be equal to how much? 685 divided by 1.85 is 370 nautical miles. 370 nautical miles. Okay. So 685 kilometer or 370 nautical mile. Now we have to find the final destination. Okay. What will be the latitude? Now when on a particular, let's say this is your Earth. Okay. We have meridians converging at North Pole and South Pole. Like this. Right? So now let's say we are at 2 degree 20 minutes north. We are at 2 degree 20 minutes north. And when we go in the southerly direction, we have to find our next latitude or final latitude. Okay. We have to find a final latitude, which is this. We don't know that. We have to find that out. Okay. So now when we travel in a southerly direction, our latitudes will change, but the meridian or the meridian of longitude will remain the same. So our final destination will have the same longitude, which is, let's say in this case, whatever, if this is 10 degree east, so our final longitude will also be 10 degree east for both places, right? So that is one important concept you should know. When you follow a particular meridian, when you fly along a particular meridian of longitude south or north, okay, you fly along that meridian continuously. What changes is the latitudes, okay, and therefore this will be, now meridians of longitude are great circles, okay, a meridian and an anti-meridian together become a great circle, right? So we call meridians of longitudes are great circles. Okay. When we follow a great circle track along a meridian, the meridian longitude is going to remain the same. The latitudes will keep on changing. Okay. So now we have not been given any longitude in this question because it's useless. Longitude is going to remain the same. The latitude will change. So let's find this out. Now this is your Earth. Okay. And there is equator over here, 0 degree equator. Now as long as you are in the northern hemisphere, that is any latitude above 0 degree equator, when you fly a southerly direction, the latitudes decrease in value. 90 degree will become 60, 50, 40, 30, so on and so forth up to 0 degree equator. So as long as you are in the northern hemisphere and you fly in southerly direction, your latitude value will decrease up to 0 degree equator. When you cross 0 degree equator, continue your 180 degree heading, you will enter south hemisphere. When you enter south hemisphere, the value of latitudes will increase. So 0 degree will become 10 degrees south, 20 degrees south, 30 degrees south, okay, so on and so forth up to 90 degrees south. So remember this, in the northern hemisphere, going south direction, latitude value decreases. In the southern hemisphere, going in the southerly direction, latitude value will increase. So let's find this out using a great circle distance, because meridians are great circles. So great circle distance is d log in correction d lat in degrees into 60. So great circle distance is 370. Difference in latitude we don't know, into 60. D lat is 37 divided by 6. 6 degree 10 minutes. It is equal to 6 degree 10 minutes. Okay. Now total D lat is 6 degree 10 minutes. Total D lat is 6 degree 10 minutes. 6 degree 10 minutes. Out of that, 2 degree 20 minutes is traveled in the northern hemisphere. 2 degree 2 degree 20 minutes will be traveled or will be crossed in the northern hemisphere. So out of 6 degree 10 minutes, 2 degree 20 minutes are covered in the northern hemisphere. The rest will be traveled in the southern hemisphere. Okay, so let's find that out. So out of total 6 degree 10 minutes, we have 2 degree 20 minutes in the northern hemisphere, and the remaining portion or distance will be covered in the southern hemisphere. So how much is that we don't know. So let's consider x. So the distance covered in the southern hemisphere, the remaining distance will be equal to how much? It will be equal to x, which is equal to 6 degree 10 minutes minus 2 degree 20 minutes. So x will be equal to 3 degree 50 minutes. 3 degree 50 minutes. So when you cross the equator and travel southerly direction in the southern hemisphere, you will cross 3 degree 10 minutes. So that means the new latitude is 3 degree 10 minutes south latitude. 3 degree 10 minutes south latitude. Correction, 3 degree 50 minutes south latitude. 3 degree 50 minutes south latitude. Okay. So 6 degree 10 minutes was a complete total. Out of that, 2 degree 20 minutes in the north, 3 degree 50 minutes in the south. So the closest option is the accurate option is option Bravo. 3 degree 50 minutes south. Pay attention to the latitude. That's why always draw a diagram like this and label it, and then draw the same diagram on the planet Earth, so you get to know whether you're located in the same hemisphere or you transition from one hemisphere to another hemisphere. Next question. Question 48. The departure between two positions is given to you, and what is the longitude of final position, right? So same. When we are talking about departure means rum line, we have to draw a diagram for longitudes, and the diagram for longitude always is something like this. North, you are looking at the earth from the north pole, 0 degree, 180 degree east, 180 degree west, 90 east, 90 west. So first position is 60 north, 160 east. So 60 north, 160 east, and the other longitude we have to find that out. Total drumline distance is 900 nautical miles. Now both of them are located at same latitude, 60 degree north, 60 degree north. Okay, that means let's say when latitudes are same, latitudes same, that means let's say this is your earth. Locations in the given diagram, both are located at same latitude. One is at 160 degree east, another I don't know, it may be somewhere here. Let's take it x. So you are traveling from 160-degree east to the next point. Okay, you're traveling from A to B. So you will travel either westerly direction from A to B and reach X, or you can travel easterly direction and then you can enter from this side. Easterly direction and you can enter from this side. Okay. Either way, either direction you are following a rumline track, because you're following or you will be flying along a given parallel of latitude. The latitude is going to remain the same. What will change is the longitude. So when latitude is the same and longitude changes, so we are talking about departure or rumline distance. We are talking about departure or rumline distance. In case of great circle, a meridian of longitude remains the same. A meridian remains the same. Latitude changes. And in case of rumline or departure subs, a latitude will remain constant. The longitudes will change. The longitudes will change. Okay. The longitudes will change. You're traveling between different longitudes, across different longitudes. So let's use this formula. Rumline distance equals to d long, the difference between two longitudes in minutes, into cos latitude. So distance is how much? 900 miles. D long is in minutes, into cos of 60. So solve this. 900 into d long into cos 60 is how much? So d long in minutes equals to 900 divided by cos 60. 900 divided by 0.5. Cos 60 is 5. So d long in minutes is 1800 minutes or 30 degree or 30 degree. Okay, so that is the total difference between two longitudes. Out of that, we know one longitude is 160-degree east. So now we have to find another longitude, and that new longitude will be at a distance of 30 degree east or west. So let's check the direction given in the question. So, so the direction is not specifically given to you, whether you're traveling west or east. Okay, but uh, so let's find out. We have two possibilities, right? So when the difference is 30 degree, okay, our final longitude, if we have two directions. We can travel westerly direction, easterly direction, which is anti-clockwise, or the plane can travel in the direction of west 270, and westerly directions are clockwise. Westerly directions are clockwise. Okay. So let's say we travel clockwise, that is westerly direction. 270 heading, at a heading of 270, so 160 east, and we follow westerly heading and we travel in the direction of 270. So our new longitude will be what? So new longitude will be 160-degree east minus 30 degree, which is your D long, right? So westerly direction we are following. That means from 160-degree east, I am traveling a direction of 270. So when I travel in the direction of 270 or westerly direction, our angles or our longitude values decrease. 180 has become 160 clockwise, 160 has become 90, 90 has become 0. So if you are in the eastern hemisphere and you travel a direction of westerly or clockwise direction, values of longitude decrease. So 160, that's why I'm subtracting a difference of 30 degrees, subtracting because of decrease from 160. So our new longitude will be 160 minus 30, 130 degree east, 130 degree east. Okay, that is one possibility. Second possibility is if we travel a direction of 090 or anti-clockwise direction, like here from 160 east, I'm traveling 090 clockwise direction, and I will enter from this side of the earth. So what will be a new longitude? So in that case, when you travel anti-clockwise 090 degrees, you will add the d long. You will add d long. So anti-clockwise direction is like this. So starting from 160 east, if you go anti-clockwise, your longitude values will increase. Your longitude values will increase. Your longitude values will increase. So that's why I'm adding. And the new longitude will be 160 plus 30 is 190 degree. But do we have a longitude of value of 190 degree? No. The maximum longitudinal value can be 180 degree east. So we have 190 degree. That means 10 degree more than 180 degree. So that means in this scenario, we are traveling this crossing this anti-meridian and entering the next hemisphere or the other hemisphere, which is western hemisphere. Okay, after crossing 180 degree anti-meridian, we enter western hemisphere. So our new longitude will be 190 degree. So new longitude is 170 degree west. 170 degree west. 170 west. So 180 degree and extra 10 degree. So after traveling up to 180 degree, extra 10 degree will be 170 degree west. 170 degree west. So our first possibility was 130 degree east. So 130 degree east is not in the options here. And the second possibility, traveling easterly direction, we can have a new longitude 170 west. So 170 west is in the option. So option A is the correct option. Okay. Let's go to the next question. Question 49. Aircraft is at position 60 north and 005 degree west. It flies easterly direction for 315 kilometers. After the completion of the flight, what will be its new longitude? So same, we are at 60 knot 5 degree west. So let's draw this. So I will draw two types of earth here. One, the physical map. So this is your 0 degree longitude. This is your 180 east and this is your 180 west. Currently we are traveling 090 easterly direction. That means we are flying a drumline track. The latitude of both positions will be the same. Longitudes will change. So 60 north, 5 degree west. So 5 degree west is, let's say, this. This is 60 north. So currently we are located at this position. Okay, 60 north, 5 degree west. Now from here we travel easterly direction. Right? So there are two possibilities. I can travel a direction of 090 and I can still be in the western hemisphere, not crossing the 0 degree prime meridian. Or the second possibility, I can continue traveling easterly direction, cross this 0 degree prime meridian and enter a new hemisphere, which is eastern hemisphere. So we will have eastern longitude. Or if I don't cross 0 degree prime meridian, I will stay in the western hemisphere with a new longitude bearing westerly direction. Okay, so there are two possibilities. Next, let's check. Let's draw another earth that we always do, like this, one for longitudes. North 0, 090 east, 090 west, 180 east. So we are at 5 degree west. And when we travel 090 directions, we travel anti-clockwise. Anti-clockwise directions. Easterly directions are anti-clockwise directions. So our new longitude can be either between 005 and 0 degree prime meridian or more than 0 degree. So now looking at the options, you can see all the longitudes, two longitudes are in the eastern hemisphere and only one longitude is in the western hemisphere. Okay, so let's write the formula. Drumline distance is d long in minutes into cos lat. So distance is 315 kilometers. So 315 kilometer, how many nautical miles? 315 divided by 1.85. So that is how much? 315 divided by 1.85 is 170. 170 nautical miles. D long stays like that into cos 60. So D long in minutes is equal to 170 by cos 60, 170 by zero point 0.5. So D long in minutes equals to 40 minutes, or in degrees divide 340 into 6, divide 340 by 60. 5 degree 40 minutes. 5 degree 40 minutes. Okay. So D long total is 5 degree 40 minutes. So out of this total 5 degree 40 minutes, 5 degree will be traveled from here to 0 degree. Out of total 5 degree 40 minutes, 5 degree will be traveled westerly in the westerly direction from 5 degree west to prime meridian. And the remaining 40 minutes will be traveled in the eastern hemisphere. Remaining 40 minutes will be traveled in the eastern hemisphere. In the eastern hemisphere. So 5 degree, this is 5 degree west, this is 40 minutes east. So new longitude will be 0, 0 degree, 040 east. 40 minutes east. Okay, 000 degree, 40 minutes east. So the correct option will be option A. Option A. Okay, so I hope you have understood how to solve this question. So now the D long was more than 5 degree. Okay, since it's more than 5 degree, 5 degree 40 minutes, more than 5 degree, that's why the new longitude will fall on the other side of the hemisphere, eastern hemisphere. Had this D long been less than 5 degree 40 minutes, okay, less than 5 degree, or any value less than 5 degree, it would have been in western hemisphere only. But since it's more than 5 degrees, so it is bound to enter the new hemisphere. So very simple, so this is how you draw it. So our new longitude will be 40 minutes east, 0 degree, 40 minutes east. Okay, very close to prime meridian. Very close to prime meridian. Let's go to question 50. A flight is to be made from point A to point B, and both are located on anti-meridian, 180 degree east, 180 degree west, 49 degrees south and 58 degrees south. What is the distance between these 2 points? So this is your earth, and let's say this is the back side of the earth, that is your 180 degree meridian. This is your equator. Between 49 south and 58 south. So you have to find the distance between these 2 points, between 49 south and 58 south. So when you travel along a meridian, okay, the meridian is going to remain the same as you travel from 49 south to 58 south. So as you travel along a fixed meridian between different latitudes, between different latitudes, you are actually flying what? You are flying great circle track. A great circle track. The formula for great circle is d lat in degree into 60. Now what is d lat in this case? The difference between two latitudes, 58 south and 49 south. The difference between them is 9 degrees. The difference between them is 9 degrees. So 9 degree into 60. So that is 540 nautical miles. But we are expected to give our answer in kilometers. So 540 nautical mile is equal to into 1.85 is approximately 1000 kilometers. 1 nautical mile equals to 1.85 kilometers. Therefore, 540 nautical miles will be equal to 540 into 1.85, 1000 kilometers. So option B is the correct answer. So very simple, direct formula based question. With this, we have come to the end of this fruitful lecture. I hope you have understood how to solve these sums and all the sums so far we have done. I hope your confidence is gaining day by day and it's going up day by day. And also on top of that, I want to say that keep practicing the questions from R.K. Bali, Keith Williams, and Oxford. Do like this video and subscribe to the channel, most important, so that whenever I put a video which contains departure sums like this from any other resource, you will get a timely update of that. And also share this video with all your friends. Thank you. All the best.